Yo YouTube, how's it going? I wanted to make a quick video on how to make API requests in a React application. This is something that I feel like a lot of beginners kind of get confused about. So let's jump right into it. First of all, I think there's a couple of things that you ideally should already know. You should have React fundamentals, right? You can't even do this if you don't already know React. You should have a good understanding of promises, so anything that you do in your application that makes a request to something external that doesn't respond immediately, right? That always returns a promise most of the time. So API requests, if you're making calls to a database or something like that, all of those will revolve around handling promises. So you need to have a good grasp of promises. I won't cover that in this video, but there's a ton of resources about it. Let's see. It's very useful to know and understand hooks in React, which is it's a fairly new concept, but it's been around long enough that if you're doing any kind of React development, I suggest you definitely take the time to learn and understand hooks. So the two main ones that I'll probably use in this video is the useState hook and the useEffect hook. So I'll use that in my examples today. So make sure you have a decent understanding of how that works. And then the only other thing you really should know about is you have to have a way to make HTTP requests. So the two main ways that I've seen used a lot is either the Fetch API or this library called Axios. I personally recommend Axios over Fetch, just purely based on the API and kind of the ease of use. I find it a lot more straightforward. The comparison of the two, honestly, I could probably do an entire video on, but for now we'll use Axios. So let's get started. All right, so I have a basic React application here. I just used create React app to initialize it. It's already set up to, every time I change the code, it should automatically refresh. So you'll see here on the right side, the changes are there. So first, let's talk about how to even do these API requests, the HTTP requests. So I mentioned that we'll be using Axios as our HTTP client. So I'm going to go ahead and install that. The documentation tells me to do npm install Axios. I was going to install it, put it in my dependencies. While that's loading up, there's actually this other tool that we're going to use called Json Placeholder, which allows me to effectively have like a mock server that we can make HTTP requests to. So for example, you'll see that they have a /posts here that will return 100 posts. So if I click into that Json Placeholder blah 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 /posts, it'll give me this JSON response. So this part of it, you don't necessarily need to fully understand what's happening. If you're a backend developer, you probably already do, but basically we've got this server that if you make an HTTP get to /posts, you'll get this back. So what we're going to learn here in a second is how do we make our React application perform that same HTTP get /posts. All right, so Axios finished installing. I should now be able to import it like this. Import Axios from Axios. And then to use that, so earlier I mentioned about the useEffect hook. So we're going to import useEffect up here. do a little bit of formatting. So ideally you already know how to use the useEffect hook, but here's a little intro. You open it up like this with parentheses, and then within that parentheses you pass an arrow function like this, and then it also takes in a second parameter that we're going to provide an empty array for. Now what does that mean? This effectively just means that whatever is in this code, in this block, it will run on mount. Okay, so the very first time your this component app mounts, whatever is in here will run. So for example, if I did console.log I am here, if we go back to our application and view our console logs, so every time I hit refresh here, the application kind of reinitializes and this component mounts, and then it prints I am here. So that's a good place to make HTTP calls. It's like, so usually you might have a component that, let's say you have a component that loads these posts, right? Like maybe you have like a blog, and perhaps you want to load all of your posts when the application first loads, or when that specific component first mounts on the screen. So to make this a little bit more specific, so how do we make that HTTP call that we just talked about? So we can do Axios.get, and then I'm going to provide it with a URL of this guy, which we just showed earlier, Json Placeholder /posts. And then what I expect from this is that it's going to go make that HTTP GET request, and then it's going to come back as a promise. So I should be able to do .then, and then it's going to come back with a response. And inside that response is, let me wind this up a bit, is the data that you see on the right hand side of the screen here. So if I do console.log response.data, I expect to see these objects that I see in an array. So let's take a look at what we have here. So as you can see, when I refresh on the side, it makes that HTTP GET, and then we get back this array of objects. So that's kind of like the basics of it. Not really much more to it. Now there's a couple of things that we can improve here. First of all, how do you usually, when you get data right from an API, you want to put that data somewhere, like either in state, or you probably want to show it on the screen. So how do you do that? That's where the useState hook comes into play. If you haven't used this before, you definitely should check out the documentation, but I'll show you some of the basics here. So you can import it like this, useState, and then first you have to initialize kind of a variable for that holds our data. So the syntax is a little bit weird if you've never seen it before, but it's actually just JavaScript syntax with this structuring. So for example, let's do posts, set posts, and this will make sense in a second here. useState, and then whatever you pass in here is your initial data. So we're gonna have an empty array here because we initially want to have this empty, and then when the data comes back to us, we're gonna do set posts response.data, and then what's going to happen is this data will be assigned to what this variable is pointing to. So to kind of prove that out, let's go ahead and print it. So we'll do posts.map, and then what we're gonna do is for each post, we're just going to return a div that let me take a look again what this data looks like. So each object that comes back will have an ID, a title, and a body. So we'll do, how about we show the title? So post.title. So what I expect to happen here, assuming I didn't make any mistake, is that when the app loads, it's gonna make this HTTP GET call. It's gonna get back posts, and then it's gonna assign that data to this component state that we also call posts, and then down here this should load up as a list of title, which I misspelled. Let me correct that. So let's take a look at what our app currently looks like. So now we have a list of these titles. None of these make sense because they don't make sense either here. But that's kind of the basics of it. Now you have now have a way to make HTTP calls, and then take that data, and then you save it in state, and then you present it to the user, right? So very simple. There's not much to it, but there's a couple of things here that we can improve a little bit. So first of all, to clean this up a little bit, let me extract this to a variable. All right. And then, so what can we improve here? First of all, this responds very quickly. And in a more realistic scenario, you might have a server that takes a little bit of time to load up. So one thing that might be useful there is, for you to present a loading state. So perhaps while it's making a call and it's still kind of pending, it'll show a loading spinner or a message. And then once it comes back, it removes that loading spinner and presents the data. So how do you do something like that? Well, then it's pretty simple. You just need another state object. So let's say that we have something called isLoading. And then we also need a setter. Set isLoading equals useState. So we provide here the initial state, which would be false, because initially it's not loading. And then what we're gonna do here is we're gonna say on mount isLoading should be true. Set isLoading to true. Now what does that do? Perhaps let's say that we want to show this spinning React logo while it's loading. So imagine that it'll show this logo while it's loading, and then when it's done loading, it'll show this list. So how do we do that? Well, simply we just need to kind of add a little bit of conditional logic here. So if isLoading isLoading, show me my spinning logo. Otherwise, give me my list of posts. Let me format this so you can see better. Right? So the way the syntax works is it kind of works like an if-else statement. So it's saying if isLoading is a truthy value, it will show this, else it will show that. So the way we have it here, because we have it initially to set its loading to true, it'll show just our spinning React logo until we mark it that it's downloading. And at what point is it downloading, right? It's when we're done setting the data, when we actually get the data back. So this is where we would kind of turn off that flag, set is loading false. Okay. So you'll notice in application, it'll probably be hard to pick, but every time I refresh, it should show the loading spinner. And then eventually when it's done, it'll show the list of data itself. Now, right now, you're not able to see it because the browser is caching the request, but just trust that that's how it works. Now, that's great. What else can we do here? There's a thing about, anything that is a promise, or especially with HTTP requests, is that it's not guaranteed to always succeed, right? There's a possibility that it fails, like maybe the user loses internet connection, or maybe on the server side some kind of problem happened, maybe a problem with their database or something like that. So anything can happen, and how that usually works is a server would respond a different HTTP status code to kind of signal that, hey, something went wrong. So that's usually status codes that are in the 400 to 500 range. So ideally, you need to make sure that you're catching those potential errors. So how do you do that with Axios? Now, if you understand promises well, you should know that there's also a concept of promise rejection. Now, with Axios, what it will do is, if the HTTP request failed, it'll actually turn into a rejected promise. So you can add a catch block here. And for now, we'll just do console.log. We'll just log out the error for now. Okay. So we don't see anything different here, obviously, because our mock server here will almost always respond successfully. There's this other tool that we can use that is great for simulating different HTTP status codes. So for example, let's pick a status 500 here, internal server error. So if we take this URL http stat.us/500, it's going to give us basically like a simulated HTTP request that responds with a 500 status code. So if I provide that as my URL over here, and I'll just comment this out because I'll use that later, we know that it's now going to make a request to that, and it should fail, so it'll go down here. And so how do we expect that to respond on the UI? At the current state, we should just see that it's kind of stuck on a loading state, right? Because it never gets to the resolution over here. And we should expect that it logged out an error, request failed with status 500. Now that's great, but it's still not complete. Ideally you kind of let the user know, right, that your application failed somehow. So how do you do that? Maybe you want to present a message of, if something wrong happened, present in an error message. So how do you do that? Kind of same idea, right? As you introduce another variable, let's call it error, provide a setter, and we'll initialize this to nothing because initially we don't want an error. And then we'll add a little bit of logic here of perhaps if error. So if there is an error, let's just say, sorry, something went wrong. Obviously, in a real application, you'll probably have a better graphic or a different message here depending on your use case. So, all right, so the missing piece here is now that we have a new error state and that we have some logic here of if there's an error, you present a message. So we're gonna replace this log with set error, right? So this is the error that comes back if it failed to make a request. And then if that happens, we'll capture it. And then if we're able to capture it, we'll present a message. So you should be able to see that on the browser. All right, so now we're able to capture our error states and we're able to inform the user when an error happens with the HTTP request. I'm actually gonna refactor this a little bit to make it a little bit more cleaner. So what I'm gonna do is I'm gonna pull out this loading state up here, and then we'll just do if it's loading, kind of same thing, return me my spinning logo, and then over here we'll just remove that conditional. So what you should see is, now let me put this back to the working HTTP request. What you should see happen is when you load the application, just to review it, when you load the application, it's gonna make our HTTP get to get the post back, and then when it comes back to us, we're gonna capture it, save it in state, and then we're gonna tell the app, hey, stop showing me the loading spinner. So it will only go down here to this final return statement if A, it didn't error out, and B, it finished loading, right? So it only finishes loading when we get the data back. So if we go to the browser, we should just see our list of posts. So that's the basic structure really of making API requests. There's a couple of things that you can improve. For example, maybe you want to move this logic to a separate function in a different file. I would recommend that. And then or at least this part of it, the Axios.get, you might want to move to a separate file just for organization. And then, you can also turn this into a async and await syntax if you want to. So you can do something like async function get posts. And this will allow you to kind of clean up your promise syntax a little bit. If you're not familiar with this syntax, I also highly recommend learning about it. I won't dive into it too much, but basically, let me type this out. It's the same exact logic as what's happening here of make my get, and then when it's done, do this stuff, and if it errors out, capture it. So how do you represent that in a async and await syntax? So you would do a try catch block, right? Within the try is where you make your actual call. And the nice thing with async and await is it kind of looks like synchronous code, even though it's async. So in this line, I can do set posts, and I should actually call this response. Set posts, response.data, and then in the catch here, we're gonna do the same exact thing as this. And of course, our loading state. You can move this in here as well just to be consistent. So this async function here is equivalent to this promise syntax that we have here, and it's a little bit cleaner in my opinion. and then the only catch is you gotta make sure to actually call it. So that's how you do async and await inside a useEffect. It can be a little bit weird because some people might assume that, oh, can't you just put async up here? You can't actually, because the useEffect is expecting a non-async function to be passed in there. So you don't have a choice but to define this get posts inside here if you're trying to do async and await within the useEffect. All right, and then so that's effectively the same as what we had before. Works exactly the same. And that's it. That's kind of the main bare bones. How do you make HTTP requests in a React application? Now there is this other library that I would recommend. So, you know, imagine that you do, let's say you have a blog application, right? You're gonna make a lot of HTTP requests. You're gonna get posts, you're gonna load up comments, you're gonna load up, you know, probably authors, stuff like that. So there's a lot of this kind of boilerplate that you probably don't want to deal with, right? You don't want to have to keep track of error and loading states for every single one of those. So this library that I would recommend you check out, it's called react-async, and let me just install it, and then I'll show you how it works. So npm install react-async. Let me just copy this. So now with react-async installed, let me pull that in, and we'll refactor the code that we have, and you'll see how much it kind of saves. So import use async from react-async, and notice that this starts with use, which means it's a hook. So I can use it like so. Use async, and then this takes in an options object that allows you to configure what it will do. So the one thing you probably care about is promise function. This is where you pass in basically this call. And then I actually want to make sure that we just get the data back. So you'll notice that the data is always inside response. So I'm just going to put that in here. Okay. What this useAsync returns is all of the things that we pretty much care about. So it returns data. It returns, it's actually called is pending, and error. Now, each of these is pretty much what we just did here, but it's kind of hidden from you. It's done internally. So I don't need this anymore. I can just rename data here to posts, and that will be equivalent. I don't need this anymore. You know, we can use is pending instead. So I'll replace that down here. And then I don't need this guy anymore either, because that's what this is. You know, so just imagine that useAsync is doing all of that for you behind the scenes. And then this entire useEffect goes away, because what this will do is effectively the same exact thing, where on mount, it's gonna call this promise function. And then when it resolves, it attaches that resolved data to data. When it's loading, is pending becomes true, and when it fails, this error object gets filled in. So that whole thing that we just wrote is eliminated down to 3 lines of formatted code, right? All right, so that's kind of the basic fundamentals of it, right? So usually with API requests, you know, I would recommend that you're somehow maintaining loading and error states, and that you're informing the user for each of those things. And again, React-async is a great kind of library for doing basic stuff like that, like making gets. Of course, with HTTP requests, you can also do like puts and posts for creating or updating data. Not going to cover that here, but a lot of it is kind of the same fundamentals, right? That you have to manage state as, you know, whether while it's pending or it comes back or it errors out, you have to do something about it. And a lot of these libraries really help out in kind of reducing boilerplate. So React-async, I think, is a very good library for beginners. For those of you that are more intermediate, I would highly recommend checking out React Query, which has quite a bit more features. It can do the same exact thing that React-async can do, but it has other stuff. So for example, like caching, it has some the ability to retry and refetch automatically and stuff like that. So definitely check that one out. This entire library honestly could be its own full video, so I won't go into it. But it's a lot of the same idea, is that if you look at the quick start, you know, it gives you the ability to make a request, and then within the query, it has all of those stuff maintained for you, like loading and error states.